Good afternoon, ladies and gentlemen. Your attention is invited to work the learning process simulation based on the differential equations on fractional orders. Slide 2. The reform of higher education in recent years is aimed at ensuring high-quality training of specialists who have professional competencies, social skills, easily and quickly adapt to socio-economic changes and situations in their work. The increasingly important task is to conduct integrated research that can model the learning process, determine its prospects, anticipate the possible result of mastering competencies, and help identify the optimal ways of high-quality training for future specialists. Slide 3. The purpose of the study is to develop a cybernetic model of learning based on the use of differential equations of fractional orders. The proposed approach has the following advantages. Best interprets statistical data of learning outcomes, analyze the activities of participants, make a forecast for the future, find out the shortcomings in the organization of training, assess the impact of decision on future development, increase motivation, and in general, the effectiveness of training. Slide 4. During the 2019-2020 academic year at the Mikhail Strogatsky-Kremenchuk National University, an experimental study was carried out among the third-year students in the study of the discipline Theory of Electric Drive. The experiment involved 138 students who, after each lecture, passed a test of 20 questions based on the material of previous lessons, each of which contained 5-6 alternative answers. There have been 14 tests. The average scores based on the test results are shown on this slide. Based on these results, we tried to develop a model that would describe them clearly and would allow us to identify the peculiarities of students' assimilation of educational information. Slide 5. It should be noted that, starting with Ebbinghaus, many researchers talk about the exponential dependence of memorization and forgetting on time. The learning process is associated with the assimilation of information, short-term and long-term memory, forgetting, and inference. Already in the first works on this problem, Brian, Tolman, and Moss, and then Clarin, Novikov, Westerland, examining the learning curve, note that at the beginning of the learning process goes rather quickly and then slows down. The resulting dependence resembles a curve, corresponds to the first-order aperiodic blocks or a sequential combination of two first-order blocks. An attempt was made to approximate the obtained experimental data using various curves showed that the best approximation is a coefficient of determination that almost 93% has a curve formed by the sum of exponentials. The curve equation is a solution to a second-order differential equation. This coincides with the so-called cybernetic model. Slide 6. It describes well the behavioral processes inherent in biological systems and their properties, speed, accuracy, information content, and others. That's why the learning process for a group of students can be described by using a cybernetic model under certain conditions, linked to the total amount of information provided and the amount of information learned. The coefficients of the cybernetic model determine inertia, resistance to the process, and forgetting. Slide 7. For an experimentally obtaining learning curve, it is enough to simply calculate the numerical values of the model coefficients, as it is shown in the slide. It was found that the value of inertia of the educational process is 30 days, and the resistance to the process is almost 6 days. This perfectly characterizes the so-called swing of students at the beginning of the semester. Unwillingness to repeat new material immediately after its perception at the lecture, referring to it at best a week before the next lesson. For different student groups, the values of these coefficients may differ slightly. This theoretically obtained data make it possible to plan educational work, the introduction in additional consultation, the use of group works of work, method of can maintain attention, activate memory and thinking. Slide 8. However, we see that the second order theoretical curve does not accurately describe the experimental data, especially in the middle and at the end of the process. The total error depending on the initial bias is the 5.67.3%. We usually explain this difference by the difference between the individual mental and physiological parameters of the learners, based on the peculiarities of the nervous system. But this can be taken into account by adjusting the cybernetic model, based on the use of fractional differential equations. Why hasn't this happened before? Answer is simple. Scientists in the field of pedagogy, as well as many others, did not have the mathematical apparatus of using fractional order equations. But with modern computers, this is no longer a problem. Based on the Riemann-Liouville or Grünwald-Letnikov forms, fractional integrals and the derivatives are calculated quite successfully. And in the works of Vassiliev, Novikov, Uchaykin, it is proved that the models and simulation of dynamic process, which are the process of information accumulation, go beyond equation with derivatives of the integer orders. Slide 9. Let us investigate models based on differential equations of fractional order according to the result of learning. Piecewise, linear interpolation was carried out between known nodes for data processing with a constant step of 1 day. We considered several models. Initial data and the approximating dynamic function are shown in the graphs on the left. There are graphs of the change in root mean square error and the order of fractional component in the model of an iterative search for a solution, which demonstrates the convergence of this process on the right. Slide 10. The calculated parameters of several models are presented on the slide. However, in the last case, several combinations of parameters can be obtained with the same accuracy, which indicates that the model is redundant. But in all cases, you should pay attention to the best coincidence of the calculated and experimental graphs in the middle and final parts. We focused on the combination of inertial and fractional aperiodic components, which provides the smallest root mean square error and convergence to one combination of parameters. Slide 11. We identified 3 groups of students based on the study of the learning process. First, students quickly reached the maximum level of assimilation of information content. Second, students quickly reached the average level and then slowly improved it. Third, students slowly assimilate the content of the educational materials. The study of the works of Smirnov makes it possible to determine the factors influencing such differentiation. Psychophysiological characteristics, level of intelligence, creativity, educational motivation, values, self-esteem, general and special abilities, and other. Examples of mathematical models models which describe students of different groups, and the corresponding graphs are presented on slide 12. Thus, the neurodynamic and psychological characteristics of a person which affect the effectiveness of learning can be taken into account by a cybernetic model using equation of fractional orders. However, it should be noted that the study did not take into account the time parameters of forgetting and the formation of inferences. They are represented by general coefficients which limit the possibility of developing an individual learning model. Therefore, among the prospects for further work, we see the possibility of describing cognitive process by differential equations with fractional powers and taking them into account in the general model. This will make it possible to move from single equations to a system where the interdependence of all parameters will be established, which will allow developing individual learning models for each student. Slide 13. Thus, the developed cybernetic model of learning based on different equations with fractional orders allows you to describe the learning process more accurately, quickly react to changes in the assimilation of information by students. We can increase the efficiency of assimilation of information, allow to formulate an individual trajectory of a student's development in a directed manner, improve and optimize the schedule of training session, teaching methods and the system of control measuring. Thank you for your attention.